This is Ali Nasehi, and this is my YouTube channel. Make sure to subscribe my channel for further videos. What ICs I'm going to talk about. So one of the things that we have to consider is boost capacitor. The boost capacitor must be sized no bigger than 120 nanofarad or more than more than 50 nanofarad to ensure proper operation of LT3763. Use 120 nanofarad for high current switching MOSFETs with high gate charge. I prefer to choose 220 nanofarad. Uh, the input VCC capacitor selection. The bypass capacitor for the input VCCP should be larger than 22 microfarad to ensure stability, and it should be connected as close as possible to the exposed pad underneath the package. The soft start pin, unlike conventional voltage regulators, the LT3763 utilized soft start function to control the regulated inductor current instead of the output voltage. The charging current is 11 microampere and reduces the set current as long as the SS pin voltage is lower than control 1 and control 2. Output current regulation. To adjust the regulated load current, an analog voltage is applied to the control 1 pin. Figure 5 shows the regulated voltage across the sense resistor for control voltages up to 2 volts. As you can see, more than 1.5 volts on V control 1 pin could not affect any in the output current. Input current monitoring. User can monitor the input current at the IV-in pin, which produces 0 volt to 1 volt as the voltage between IV in positive and IV in negative varies from 0 millivolt to 50 millivolts. Those are the feedback pins that I have talked. You could send them to your microcontroller in order to get the data from your LT3763 driver, and based on that you could consider if your circuit is working good or not. Output current monitoring. The LT3763 the capability to monitor the output current as the voltage provided at the ISMON pin. As I told you, the output current is measured by this pin, and the input current is measured by IV in mod. So make sure to have both of them sent to your microcontroller in order to measure how efficiency your circuit is working. Voltage regulation and overvoltage protection. The LT3763 uses the FB pin to regulate the output voltage and to provide an overvoltage lockout to avoid high voltage conditions. The regulated output voltage is programmed using a resistor divider from the output to the FB pin. So in our circuit, you could see that in this circuit, you could see through the resistors that are connected to EN and EN pin, you could see how your circuit works. And the output voltage could be calculated from this formula. Based on the output feedback resistors, you could calculate what your voltage could be. Actually, as you know, in our constant current circuits, Our circuit tries to control the regulated output current but has no limit on the voltage. But this circuit allows us to limit our maximum voltage that we want. For example, I could tune my circuit to work around 4 volts at the maximum, and my current could be around 20 amps. So whenever I want to give 10 amps to my load, it tries to lower down the output voltage so that my load can get around 10 amps. But if my load wants to get around more than 20 amps, so it has to go higher than 4 volts. So my circuit won't allow the load to get more than 20 amps. Here we are going to talk about the fault detection. Our IC has a mechanism that we could get whenever we have a fault operation, we could send it to our micro, and our micro could get the status of our IC. So it's really good to send it to our micro. In the fault detection, the L3763 detects that the load has an open current or short circuit event indicated by pulling the fault pin to ground. The conditions These conditions are detected by comparing the voltage at the FB pin to two internal reference voltages. A short circuit is defined as F voltage F feedback lower than 25.25 volts. In an open circuit condition, the regulated inductor current will charge the output capacitor. The voltage at FB will begin to increase, and the voltage error amplifier will begin to reduce the inductor current. The open circuit condition will be indicated at fault when F feedback pin is higher than 1.16 volts and the inductor current is less than the 10% of the maximum value set by the sense resistor R series. The output voltage will be regulated as determined by the resistor divided to the FDP. And here we go about low current detection. When inductor current decreases to 10% of the maximum current, the comparator will also disable the low side gate driver so that the converter will become non-synchronous and automatically transitions into discontinuous conduction mode when the inductor current is low enough relative to the rest. The low current condition is an essential part of the battery charging application. The LT3763 works well in this application, delivering a constant current to the battery as it charges and then automatically reducing the current to the trickle charge as battery voltage approaches its full charge value. In this application, the signal at a fault triggered by the lowest current detection comparator serves as an indicator that the trickle charge phase of charging the battery has begun. And the next one that is very important is the output switching frequency. This is very important because all the calculations that you get into your circuits to work with is based on this frequency. As you go higher, you have a lower value inductor, but your PCB considerations must be higher. So programming switching frequency, the Alpha 7 has an operational switching frequency ranges between 200 kilohertz to 1 megahertz. This frequency is programmed with an external resistors from the RT pin to ground. Do not leave this pin open under any condition. The RT pin is also current limited to 55 microamps. Based on this table, you could see in which frequency you need what value of resistors. For example, if you want your circuit to work with 1 megahertz switching frequency, you have to choose your resistor value around 40.2 kilo ohm. In our designs, mostly we choose our resistors around 100 kilo ohm so that our circuit could work around 400 kilohertz. Our IC also supports external clock so that you can switch the MOSFETs with an external clock. I haven't worked with this feature, but it's good to it's good if you want to program it from an external clock. The next thing that is very important is PWM driver. Mostly in our cases, we have a series MOSFET with our load so that we can open circuit our load whenever we want to based on the voltage on the PWM pin. You could see in the picture, you could see that here is a MOSFET series to our load. So if you want your MOSFET to, here is the MOSFET and here is our load. So based on the voltage on this pin, you could open circuit our load from our circuit. Here is a guide about how to choose your PWM MOSFET. The rated via the range source for the PWM MOSFET needs to only be higher than the maximum output voltage. Also, this permits a MOSFET choice with a smaller gate charge specification than out of the switching MOSFETs. It will have little effect on efficiency because the PWM switching frequency will be much lower than that of the switching MOSFETs. Power loss charging, the gate charge of PWM MOSFET will naturally be much lower than the output loss charge in switching MOSFETs. Drain source resistor conduction losses in the PWM MOSFET will also be much smaller if the duty cycle of the PWM signal is very low. Like the drivers for the switching MOSFETs, the P drivers draws power from the in VCC pin, and the choice of MOSFET should follow the same recommendations for threshold voltage, less than 2 volts, and rated gate source. Voltage of the gate source. The thermally shutdown. Our IC also supports thermally shutdown. Whenever the temperature goes higher than 165 degrees Celsius, it terminates all the switching. And when the part has cooled to 160 Celsius, the internal licit is cleared and the soft start capacitor is allowed to charge. Here is an our IC also supports our IC also support you can follow it in the datasheet, but I haven't worked with this feature, so it's kind of good to measure our output temperature and send the feedback to our IC so our IC could control the output current and it leads to a lower temperature on the output load. And the last one is those average current control compensation. And you have to connect a series resistor and a capacitor in series to the compensation we see on the IC pins so that it can tune our loop. Those series resistor and capacitor could be calculated from these formulas. And the last one is the board layout considerations. Here